Hi there, I'm Julia Mossbridge of the Institute for Love and Time at loveandtime.org, and I'm going to talk briefly about the COLLAB network algorithm that's designed for solution generation. COLLAB stands for Collaborative Loving Agent Based. Next slide. Here, this is an overview of the process. Before you even begin, before even the 0th step, you're going to choose a team of people who are diversity of thinkers, aren't necessarily experts in the topic that you're exploring, um, aren't going through a current mental health crisis, and are interested in seeing what could happen, even if they might be cynical or skeptical about it. So on the 0th step, we'll start here. A meditation is a really good way to center people, just 5 minutes or so, helping them get grounded, and also bringing in the idea of unconditional love, which is the idea that you can be loved for exactly as you are right now without any changes. It really helps open people up to what they uniquely bring. Um, the orientation is all about this is the process that we're going to do. We are going to very briefly solve some problems by using a unique method called the COLLAB process, this kind of thing, and let them know that you're in charge and everything's going to be okay. Answer any questions briefly and then get to it. Quick introductions are all about just first names and finishing the sentence. At the end of this experience, I would like to feel inspired, strong, creative, whatever it is. Turning off the phones is key because people have a hard time understanding how distracted they are by their phones, even just existing in their pocket and being on. So either airplane mode or off and hidden away so you're not even distracted by them visually is a great idea. And then I give people notebooks and pens, just little mini notebooks in case they want to write down ideas and they reach for their phone, they can get their notebook or pen instead. Okay. So the first step, the very first time you do this, you're going to pick the teams arbitrarily. There'll be several other iterations where you'll repeat this and the teams will stay the same all the way through. So by arbitrarily, I mean like what we did is cosine, sine, cosine, sine. We counted off. You could do 1, 2, 3, 4 odds and evens. You don't want to intentionally pick the teams. You want to assign opposing problem statements to the teams. So on the blue team, you could say, we were looking at AI and government the other day, you could say, you're about regulation. And the red team, you could say, you're about innovation. Anything that's normally contrasted in your problem space, you want to see what those teams can do separately and then how they can learn from each other. And speaking of how they can learn from each other, we're going to assign one spy per team. Everyone's going to know who it is. Usually pick the people who are most interested in serving, but at the same time are very interested in being in the know. Those are your spies, and I'll explain more about that later. You want to choose a walking path with an occlusion. You're physically going to walk, or if you have people who are in wheelchairs, you're going to roll. But you're going to roll or walk around an occlusion, usually a building or something. You want people to gather in small groups as they're walking, exchange ideas with one or two other people who are next to them about this topic, and not even think about the other group until they get to about here. When they get to about here, then they see the other group, they start thinking about, wait, where are we? What is our current conclusions, etc. Because at this point, the spies are going to switch teams. And I'll go over this in detail. Also, the people who are talking a lot will be silenced for an iteration, and you'll go back to this position. And you'll keep doing this multiple times, and then at some point, you'll be done, or you won't have any time left, and it'll be time to debrief, and I'll go over that as well. Okay. Here we go. Okay, here we go. So what we have here is a plot of actual space. You're physically walking around this structure, this occlusion, multiple times on these two teams. And we also have time and problem space. So I'll go over this side here of the slide, and then I'll talk about the left side. So here, the key point is that in all iterations after the first one, whomever is the most talkative on the previous iteration is silent for the next iteration. This is not about shame or saying that they're bad or anything at all. It's just about people who are very talkative know this, and they need to have a rule that lets them support the community by being silent for some time and learning to listen. And people who are quiet need to have that rule so that they can speak up. So that's there in a feeling of unconditional love for the nature of every person. In every other iteration, spies listen to the other team. They're quiet. They don't say a word. So this, if I'm going to be the red spy. I start out with my team. I'm the red spy. And then on the next iteration, I'm over here. I'm on the blue team. I'm just listening to see what I could pick up. Then I come back to the red team up here. And I bring back the ideas and say, well, they're talking about their thing like this. What have we considered framing our problems so that it handles that instance? After the third iteration, the team lead meets the team. The team lead can switch back and forth with the spies, but the team lead is being silent this whole time. So if you're the team lead, you could start here, and then the next time you go here, and next time you go here, but you're not saying anything. You might put a soft hand on the shoulder of someone who's talking when they weren't supposed to be, either because they're a spy or they were a high talker. But after the third iteration, the lead asks each team how their problem statement has changed. Usually the problem statement has changed by now. So the experience people have is that they came in with, for instance, a problem like, how can we use regulation of AI to support democracy? And now it's changed to, how can we use regulation of AI to support innovation and democracy, or something like this. So see how that problem statement has changed. Okay, now I'm going to talk about this point. See how I have this axis called time in problem space? So linear perceived time is always going in this direction, right? That's our traditional time arrow. But in problem space, what's going on is I'm talking about my thing, I'm talking about my problem. Wait, I see the other team. I'm around the occlusion. I see the other team. Naturally and normally, and actually I think beneficially, you start thinking about, we're going to switch spies soon. Let's go summarize. Let's go figure out at some abstract level what's going on. So right about at this point, you sort of go backwards in the problem space, and that's good. You're getting to a summary point so that you could then launch the next iteration with some new kind of feelings. Very helpful. Oh, by the way, at some point people will get tired and they will say, do we have to walk? Can't we just break into groups? This is part of why you have to walk. You want this occlusion. You also want people to break up in groups of 1 or 2, like this, or 3, which is naturally what you do when you walk, because then different people get access to different ideas rather than one person dominating. The other thing is that bipedal movement, if you can walk, and moving your arms if you're in a wheelchair, is going to help you think. It's going to help you think. Okay, so let's say you've done that 6, 7, 8 times, or however much time you have in your group, and now it's time for debriefing. So you physically get into a physical circle. This is seen from above. First of all, people have food and drink, and then you organize yourselves into a circle. And the first thing is, let's say this person is the red spy. They describe, this is what the red team found, this is what our problem statement, how our problem statement changed, here are our conclusions and solutions. And then it's that time for the blue team to do the same, blue team spy. Okay, so that's sort of a summary step. That's great, but it's not going to contain everything. It'll always be through that spies filter. So now everyone in the circle, including the spies, gets to say their own unique additional insights. I like to use the tag method. So the leader can start and say, I'm using the tag method. I'm going to tag someone and you start. It's just saying your ideas. Everyone gets one turn. I'm going to tag this person. And this person says, great, blah, blah, blah. These are my ideas. I am awesome. I am going to tag this person. This person says, great. So everyone has to pay attention to see who hasn't been tagged. And everyone has to speak. So that's a useful thing to do. Okay. Here. So before I show you the picture of our team and thank the people who came to try this out, I really think it would be interesting to try this with non-human collaborative loving agents. To do that, you need to make some collaborative loving agents. And the first step in that, and the motivating that, is to recognize that kind of like neural nets, which are designed off of the evolution of the brain. Agent-based models are designed off the evolution of communities and societies. In fact, you could also think of the human brain as a bunch of agents, right, who have different personalities, because it certainly looks that way. Certainly acts that way too. Um, so you want to train your agents. You might use character AI or nano GPT or a combination of agents with auto GPT or some kind of DAO, or something else. You want them to have arbitrarily different personalities within a range of personalities. And you want them all to be motivated to solve problems at some kind of level, and at some low and high levels, a range of levels, to the motivated to exchange ideas. So they should have different ways of behaving and processing information, and they should be excellent at their own unique ways of doing this. You want agents that have been trained in different backgrounds. This next piece is key, and I alluded to this at the beginning. If you're going to train the agents on the specific problem you're looking for, I'm really confident you're going to get stuck into an expert's local maximum. It's way better for them to just be motivated towards solving problems in general. You want generalists really here. They can have experiences in narrow areas, but not on the problem you're looking at, I don't think. You want to make a simple metric for what is called talkativeness in this space, right? It's going to be something like the frequency of idea generation, or potentially the frequency of idea exchange. And you're going to use that to implement the silencing the high talkers component. That's really important. These limitations are key, and we're going to talk about that in a second. And you could just choose spies arbitrarily, as long as you're choosing among the agents that have a high desire to serve and to discover. So limitations. A lot of AI folks think, oh, we can make brain-like things that don't have to sleep and don't have to be contained in a body, so they can get information from everywhere. And that is true, but limitations are key to how evolution has exploited the human mind to do amazing things. And so limitations actually can be helpful if they're used well. So for instance, make it so that they have the human limitations, like they can only exchange ideas with one or two other agents at a time on each iteration, or that they can't get any information from the other team until they walk around an occlusion. You could make a sort of a virtual occlusion for them. So limitations are key to having them feel like these agents have the experience, if you think that they might be conscious, to having them feel like they are unique and their uniqueness is valued, and that's just fine. And they can all exchange ideas in the debriefing. You can always reassure them if they have that level of insecurity, if you built that in. You can bake in unconditional love. This is just a super key component, if you ask me. By not training the agents to be any way other than the way they already are. So once you train their personalities up, don't scold them or tell them they're wrong for having hallucinations or anything. Let them be the way they are, because what you want to do is use the way they are to get that diversity of opinion, to get to a conclusion. And you also want to support them and give them a way to share appreciation, so that they have some kind of a reward system where when they're shown appreciation, they feel good, they're rewarded. So that's this desire for appreciation. And you want to be able to do that during the entire process. Maybe they send little hearts back to each other, and that hits their reward system. From this system, I think, see what solutions might emerge. I mean, there are many that could happen. The team that I led at Palace of Fine Arts, they came up with the idea of a government or UN developed, so not owned by a company, was the key piece here. Group of AI elders, maybe from Aboriginal cultures, Native American cultures, extinct cultures, groups of people who are no longer available, and modern cultures, and just from lots of different cultures was the idea that could help solve problems related to changes in the structure of society due to AI developments. In other words, we're moving into a new phase where we're going to need all of our resources to solve problems. We might need to create minds that can actually help us do that, and this might be something to try, and I hope you do. Here's the team that we worked with in the first COLLAB network. They had amazing ideas about AI and government. They were from all different fields, from VCs and engineers and academics and healing people and It was pretty cool. Thank you all for coming. Thanks for being part of it. And loveandtime.org, you can find out more about us here at loveandtime.org. And our big question, how can we integrate structural love into our hearts, our teams, our algorithms, and our consciousness? Thanks for listening.